Alright guys, in this video we'll be checking out the method of reduction of order by the Lambert. Alright, so given a second order ordinary differential equation, homogeneous linear equation to be precise, where a naught, a2, a3 belongs to the set of real numbers and complex numbers and complex values. So we have r of x. The r of x is a solution of the is also a solution of the homogeneous linear equation, and it is given below. So when r of x equals to 0, it becomes a solution. So we are supposing that y equals to u of x is one of the solution of the second order ordinary differential equation. So if y equals to u of x is one of the solution, then the general solution can be found by substituting y equals to u of x times a of x. Then equation 1 can then be written as pxy prime prime plus qxy prime, since we already said y equals to u of x. So pxy prime prime plus qxy prime plus rx equals to 0. And on substituting y equals to u of x, our equation 3 can be written as pu prime prime. Since y equals to u of x, we have it to be pu prime prime plus qu prime plus ru equals to 0. And we already make an assumption that let y equals to u of x. So this means that it can still be written as y equals to a of u. Why? Because we already said the general solution can be found using y equals to uxax, which can still be written as a of u. And when we differentiate using product rule, we have it to be a prime of u plus au prime. Differentiating the second time, we have a prime prime u plus 2a prime u plus u prime prime of a. Then we substitute all our values back into equation 3. So on substituting, we have it to be p open bracket a prime prime u plus 2a prime u prime plus u prime prime a plus q open bracket a prime u plus u prime a plus ra of u. Then when we open the bracket and take out the like terms, we have it to be a. We brought out a as one of the like term. A prime is also a like term, and a prime prime is also a like term. But don't forget, from equation 3, we have pu prime prime plus qu prime plus ru to be equals to 0. Then we substitute it back. Then we let z to be a prime, such that z prime will become a prime prime. So we substitute z and z prime to that expression above. So we have it to be z2pu prime plus qu plus pz prime of u. So in our next video, in this same video, we'll be taking an example on method of reduction by the Lambert. Alright guys, this is an example on reduction from Lambert's method. Alright, so we have 2x plus x squared y prime prime minus 1 plus xy prime plus 2y equals to 0. Given that, so we are given a certain condition that y is equals to x squared as a solution. But recall that from the previous example, we said y equals to ux a of x, but u of x is representing x squared in this case. So we have it to be y equals to ax squared, such that y prime, we differentiate it once, we differentiate it the second time, then we substitute our values back to the initial expression. So on substituting, we factorize out a prime, and a prime prime. You can see a will surely give us 0. So when solving using Lambert's method, the coefficient of the corresponding values, the corresponding values of a should always give you 0. So we have it a of 0, then a prime 6x squared plus 2x raised to power 3 plus a prime prime 2x cubed plus s raised to power 4 equals to 0. Then we let p become a prime such that p prime become a prime prime. Then we substitute back our initial value and we reduce the variables there. So on reducing, we have it to be p2 open bracket s plus 3 equals to minus the p dx. Don't forget the p dx is still the same thing as p prime, so we have it to be x plus 2. And then the next step, we separate the variables. So on separating, we have it to be 2x plus 3 over x plus 2, so that the left hand side integral is actually an integral on partial fraction. So when using partial fraction, we solve out. We have our value for a to be 3 over 2, b to be minus 1 over 2, and we have ln p. The p over p will give us ln p, so ln p equals to minus 2 integral of a over x plus integral of b over x plus 2. But we have our a to be 3 over 2 and b to be minus 1 over 2, so the 2 cancels out. So we have it to be ln p equals to minus 3 ln x plus ln x plus 2 plus ln k. Since c is a constant, we can write it as ln k. Then applying laws of logarithm, we have our final answer to be that. So we have it to be a equals to minus k 1 over x plus 1 over x squared plus c. And looking for LCM in this case, we have ax squared equals to kx plus 1. But what is ax squared? Ax squared is already given as y. So the other step that I didn't explain, kindly go through them. They are easily understandable.